This is an explanation on how to use the motors with the Zumo robot. Specifically, how to use the motors with dead reckoning. That is, basically just tell the motors to turn on for 1 second, and however far we go during that second, that's how far we end up going. To begin with, of course, import the Zumo library. I also create 3 instances of classes. One for the LCD screen, so we can display stuff. Another one for the motors, so Zumo 32U4 motors. And also for button A. I use the button in order to go ahead and start the robot running because I don't want it to start as soon as I turn it on. I also create a constant. I like having constants up here that allow me to control how fast I want the motor to run. This is a lot easier than, say I want it to run faster, going and changing everywhere I've got that motor amount on how much power to put to the motors. It's just plain easier to do it as a constant. The setup method is pretty straightforward. I clear the screen, go to the first line, which is line 0, and print out press A. Not too much going on there. The loop method. To begin with, I check to see if the person has hit the button. I do button A single, debounced, press, and this will end up being true if the person has hit the button. If it is true, I go ahead and start running. Otherwise, this loop method is just going to run again. I wait 1 second. That'll allow the user to get their finger off of the button, which is pretty handy. Then I go ahead and set the speeds on the motor. In this case, I set the left motor to motor speed. Remember, we define motor speed up above, and the right motor. And I delay for 2 seconds. Again, this is in thousandths of a second. So I turn on the motors for 2 seconds for motor speed, and then I'm going to go ahead and stop the motors. And then I'm going to wait 1/2 second after I've stopped the motors. It takes just a little while for that robot to actually slide to a stop. Then I'm going to go backwards. So while I still have motor speed here, note that I put a negative in front of it. That'll reverse the motors at that same motor speed. I do it for both the left and right motor and go back 2 seconds, which should take me pretty close back to the same location that I was at before. At this point, once I've reversed back to where I was at before, I go ahead and stop the motors and wait a 1/2 second. Then I'm going to turn left. Note that I reverse the left motor and I keep the right motor going forward. That'll spin me around to the left. If I wanted to go to the right, I would just have a positive left motor speed and a negative right motor speed. And I flip around for 1,000 milliseconds, or basically 1 second. And then I go ahead and, important here, I stop the motors. Otherwise, I would just keep spinning. That shows you a little bit on how to actually run the motors. For more accuracy, we would want to use wheel encoders to measure the distance that the motors actually spun. And we'd also want to use the gyrometer in order to actually make sure we keep our same heading. And when we turn an exact 90 degrees or 45 or whatever we want instead of do it by timing. But this is a pretty simple way to get started and working with your particular robot.